Okay, picture this for a second. You're online, browsing for a new pair of shoes, or maybe just ordering your morning coffee. You hit that buy button. Instantly, your screen updates, the order's confirmed, and you move right along with your day. But what actually happens to your data the millisecond after you click? I want to challenge you to picture the hidden, massive, and honestly spectacularly complex journey your data takes the moment you trigger that everyday online transaction. Because it doesn't just sit in one place. It travels through entirely different worlds.
Welcome to This Explainer. Today, we're diving into a really fascinating concept, straight out of Martin Kleppmann's acclaimed book, Designing Data-Intensive Applications. We're going to completely demystify the double life of your data. We'll explore how modern data systems handle the frantic, chaotic flow of instant user transactions, and how that completely contrasts with the sweeping, massive scale of historical analytics. It's basically a tale of two entirely different databases working together behind the scenes to power the modern web.
Section 1. The Fast Lane, OLTP, Managing the Micro-Moments of User Data.
Okay, let's dive into this. In the database world, this frantic, highly concurrent fast lane is called Online Transaction Processing, or OLTP for short. Now, despite the word transaction being right there in the name, this isn't just about money changing hands. In modern software, it covers literally everything from buying that coffee to leaving a comment on a blog post to making a move in a mobile game. Your application looks up a very small number of records, usually just yours, using a specific key, like your user ID. And it absolutely has to happen with incredible, low-latency speed.
Let's bring this down to earth and ground the tech in everyday reality. Think about the characteristics of this OLTP world. When you load up your shopping cart, the database isn't, scanning the entire corporate history of the company. It's using an index to instantly pluck out your specific records. And because this system faces you, the user, directly, there is an absolute expectation of high availability. Database administrators fiercely guard these OLTP systems like their lives depend on it. Why? Because if a query runs slow here, the live application crashes, the user gets an error, and the business loses money right then and there.
Section 2. The Big Picture, OLAP. Zooming out to the macro view.
But what happens to that data after your sale is actually complete? Well, we need to pull the camera wide. Because let's be real, the executives in the boardroom don't care about your specific coffee order from Tuesday at 8 a.m. They want to know the total revenue across all stores in January, right? Or how a new promotion affected overall sales. This requires a totally different access pattern known as Online Analytic Processing, or OLAP. Here, business analysts are scanning massive numbers of historical records to calculate aggregate statistics, stuff like counts, sums, and averages.
So we really have two fundamentally different worlds operating here. On the one hand, the tight shot, OLTP. It is entirely end-user facing. It only cares about the absolute latest state of the data, your current cart, your current balance, and it usually ranges from gigabytes to terabytes in size. On the other hand, the wide shot, OLAP. This is for internal analysts making big business decisions. It represents a vast history of events over time, and it scales up massively into terabytes or even petabytes of data.
Now, what's really interesting about this slide is how cleanly it illustrates the divide. This breakdown, adapted directly from Martin Kleppmann's text, shows us that these systems are fundamentally opposites. OLTP writes are random and low latency, driven entirely by you, the customer. OLAP writes, those are massive bulk imports, handled internally. Trying to use one system to do the job of the other? Yeah, that's just a recipe for disaster.
Section 3. Building the Bridge, ETL, Moving from Chaos to Calm.
Which brings us to a really massive challenge. How does your single purchase travel from the fast lane into the quiet archives of business intelligence? We need a bridge. The core problem that necessitated this bridge is simple but severe. Imagine an analyst decides to calculate yearly revenue, and they run that massive, sweeping query on the live OLTP database. The system's resources would be completely overwhelmed. The live website would literally grind to a halt, and no one could buy anything. Because these workloads are so antagonistic, large companies separate them entirely. Let's move to it and see how this builds out in practice. To safely ferry our data across that gap, we use a literal 1-2-3 machinery known as the ETL pipeline. Step 1. Extract. We pull the raw data from all those various active OLTP databases. Step 2. Transform. We clean up all this chaotic data and mold it into a uniform, analysis-friendly schema. And Step 3. Load. We dump the standardized data into a completely separate, read-only analytical database.
Section 4. Inside the data warehouse, the final destination for derived data.
So that completely separate analytical database, it's called the data warehouse. Think of it as this sprawling, read-only metropolis where our little data point finally comes to rest, optimized entirely for heavy analytical lifting. Inside, data is organized very specifically, most commonly using a star schema. Your single purchase is now just a single row in a massive central fact table. And this is surrounded by dimension tables that act kind of like the rays of a star, holding all the metadata, the who, like the customer profile, the where, like the store location, and the what, like the product brand.
And get this, because enterprise companies want maximum flexibility for later analysis, they capture an incredible amount of detail for every single event. It is totally normal for these central fact tables to become extraordinarily wide, often capturing well over 100 attributes per single event.
But here is the catch. Even though a single row might have over 100 columns of data, an analyst almost never selects all of them. Actually, a typical analytical query only accesses 4 or 5 columns at a time to calculate aggregates, like grabbing just the date, the product ID, and the quantity sold. If you used a traditional row-oriented database for this, the system would still have to load all 100 columns from the disk into memory for millions of rows just to throw 95% of that data away. It is terribly, terribly slow.
To solve this massive speed problem for analysts, data warehouses pull a brilliant trick. They fundamentally flip how data is laid out on the actual disk hardware. This is called column-oriented storage. So instead of storing data row by row, it stores data column by column. If an analyst only wants the quantity sold column, the database can go directly to that specific block of data on the disk, skipping all the irrelevant data entirely. It allows these systems to scan massive data sets with incredible speed.
And this brilliantly illustrates the ultimate payoff. The grand journey of your data from the fast-paced app across the ETL bridge into the star schema, optimized by column-oriented storage, ends right here. It allows company management to instantly generate massive aggregate insights, like charting out total revenue by store, derived from literally millions of individual actions.
And to make this reporting virtually instantaneous, modern data warehouses go one step further. They use what are called data cubes, or OLAP cubes. They essentially pre-compute the math. If management runs the exact same revenue report every single morning, the database pre-calculates those sums and counts and saves them in a grid. This saves the database from crunching the raw numbers over and over again from scratch. It's a huge performance boost.
Looking at the big picture, this quote from Martin Kleppmann perfectly summarizes our exploration today. The OLTP database is your system of record. It holds the absolute truth of the live transactions. The data warehouse is a derived data system. It's a read-only view optimized for a completely different analytical task. Clearly splitting these two brings logic and stability to the complex software architectures that basically run our world.
So the crucial point is this. The internet isn't just magic. It is an incredible feat of highly organized data pipelines. The next time you click buy or like or submit, take a moment to ask yourself, how many massive hidden data architectures did your single click just travel through? From the micro moment of your transaction to macro-level analytics, your data lives a truly spectacular double life. Thanks for joining me on this explainer, and keep questioning the data systems around you.